Welcome to GDIBDA American School. Our lesson today about the drawing scale. Now, listen and look for this video. Please concentrate.
The essential understanding for this lesson is: the key on scale drawings can be used to calculate actual measures and reproduce proportional scale drawings. In previous lessons, students used ratios and proportions to represent relationships between quantities, and they applied proportional reasoning to solve problems. This lesson extends student skills by having them find actual lengths using a scale drawing, use scale factors to solve problems, and reproduce a scale drawing using a different scale. This problem is key because it uses a familiar example to introduce the concept of scale. Students compare an actual object with a scale model, and they begin to analyze the mathematical relationship that is defined by scale. Listen and look for students who respond to Part A by identifying the ratio of the lengths of the scale model and the actual airplane. Explain that the ratio is the scale of the model. Ask students if the scale can be simplified to the fraction 15 divided by 240, or 1/16. Listen and look for students who make the common error of simplifying the scale as if it were an ordinary fraction without units. Remind students that the length of the model is stated in inches, while the length of the airplane is stated in feet. The scale of the model airplane is not equal to 1/16. Ask students to identify the step that's needed to simplify the scale correctly. Listen and look for students who explain that one of the units, either feet or inches, must be converted into the other unit. Discuss how the unit of feet in the fraction can be replaced with the equivalent of 1 foot in inches, which is 12 inches. Now the unit of inches cancels out of the fraction, which simplifies to 1 to 192. As students complete Part B, listen and look for students who explain that the scale model and the actual airplane have different sizes, but similar parts and shapes. Discuss how both objects have 2 wings, 4 engines, a long fuselage, and other similar parts. Discuss how the scale is useful for calculating the parts of the model. For example, in the actual airplane, the height of the tail is 64 feet. In the scale model, the height should be 64 feet times the scale of 1 to 192, which equals about 1/3 of a foot, or 4 inches.
Okay, now listen to another video for more understanding.
How can you use scale drawings and proportional relationships to calculate actual measurements? Think about this question during the lesson. The island in the blueprint is 6 inches long. What is the actual length of the island in the kitchen? A scale drawing is an enlarged or reduced drawing of an object that is proportional to the actual object. Here is one way to solve the problem. Use a double number line to represent the scale drawing length and the actual length. The scale is 1 inch for the blueprint, is equivalent to 1 5/10 feet for the actual kitchen. This means that as the number line for the blueprint increases by 1 inch, the number line for the actual kitchen increases by 1 5/10 feet. As shown by the number lines, what is the actual length of the island in the kitchen?
Select your answer.
The double number line shows that a length of 6 inches on the blueprint represents an actual length of 9 feet. Another way to solve the problem is to use a proportion to find the actual length, x, of the island. Use the scale to write the proportion. 1 inch on the blueprint equals 1 5/10 feet on the actual kitchen. Divide both sides of the equation by 1 inch to show the ratio 1 5/10 feet to 1 inch. This ratio will be the constant scale factor for all lengths in the drawing to the actual lengths. Write the scale factor on one side of the proportion. The other side is the ratio of x, the actual length of the island, to 6 inches, the length of the island in the blueprint. Make sure to write the ratio in the same order as the scale factor. Solve the equation by multiplying both sides by 6. The actual length of the island is 9 feet.
Okay, now we move to the practical part. See you. Hi guys, today I will listen about drawing scale. What is a drawing scale? Drawing scale, if I want to draw the distance between two cities have a distance 100 kilometers, and I wanted to draw the distance between them on a paper. We can't draw cities and we draw the distance here, we measure the distance 100 kilometers on the paper. It can't be. So we use drawing scale. What is the drawing scale? We can represent each 10 kilometer by 1 centimeter on the drawing, okay, and so on. So this is our lesson, how to represent a real distance between two objects on a map or on a paper. To find the real distance or find the drawing scale, what is the equation we use? The equation is we write above the real distance and write down the distance on the map or on the paper. Look, question number 7. On a map, 1 inch equal 5 miles. So what is the real here and what is the distance on the paper or on the map? 1 inch equal 5 miles, which is greater? 5 miles is very big distance and 1 inch is very small distance. So we can represent in the paper for each 5 miles by 1 inch. So we write above the real one 5 and here the distance in the paper 1. Two cities are 8 inches apart on the map, so we write it down. Above we write the real and down on the map on the drawing. So he asked about what is the real one. We called it x. To find x, multiply two sides by what? Yes, by 8. Now x equal 8 times 5 equals 40 over 1 equals 40 miles. Okay, number 8. Ryan makes scale drawing of a banner for a school dance. He used a scale of 1 inch for 3 feet. So the real one is 3 feet and on the map or on the drawing equal 1 inch. Okay, and width of drawing scale 5 inches. So the drawing scale for 5 inches. Now I want to find the real one. Don't forget the real, we write the real distance in the numerator and we write the distance on the map or on the drawing on the denominator. Now we want to find w, multiply it by 5 here and then multiply by 5. Now w equal 5 by 3 equal 15 feet. Number 9. Okay, on a map 1 inch equals 7.2 miles. So the real distance 7.2 in the numerator and 1 on the map. Okay, two houses are 1.5 inches apart on the map, so we write 1.5 in the denominator. Okay, what is the actual distance between the houses? So call it hx and so on. So multiply two sides by what? Yes, 1.5 and 1.5. Now the distance equal 1.5 by 7.2. We can make 7.2 multiply 1.5. 5 times 2 equal 10 of 1. 5 times 7 35 plus 1 36 both 0. 1 times 2 equals 2. 1 times 7 equals 7. Adding 0, 8 and 10. Put a decimal after the decimal here after one place and one place, so after two places it will be 10.8. Don't forget to write the unit. The unit for the real object here is equal yes, mile. Okay, the last one, number 12. Okay, number 12. high thinking. Okay, the scale of the drawing of a rectangular playing field is 2 inches for 5 feet. Okay, for 2 inches equal 5 feet. So the real one is 5, and in the playing or on the drawing equals 2. Okay, don't forget, we write the real in numerator and in the drawing in the denominator. Okay, write an equation you can use to find the dimensions of the actual field, where x is dimension of the scale drawing in inches and y is corresponding dimension of the actual. So in the drawing x and actual y, so we write the actual above and in the drawing x. Okay, now multiply the two sides by x. Y equal 5 over 2x. This is the equation. We can use it to find the real distance directly. Okay, this is number A. Number B. What is the area of the field? The area of the field, the area of the real one. Okay, we can find the area of real one by find the length in real for each one, for length and width. For length, yes, we have 5 over 2 real to mapping, and here in map 20. So what is the real length? Now multiply by 20. Length equal, yes, 20 over 2 equals 10, by 5 equals 50. Length equal 50. What is the, yes, feet, the unit feet. Now we find by the same way the width. 5 over 2 equal, what is the width in map? Yes, 10, and in real I want to find it by 10. يبقى width equal 10 divided 2 equals 5, by 5 25. Now we have the real dimensions for the rectangle. So the area equal 50 times 25 equals what, 0. 5 times 5, 25 up to, yes, equal 12, 1250. What is the unit? Feet square. Thank you.